As we begin our introduction into probability, we're going to examine how good do you really think I am at free throws? I know I'm amazing, but we're going to run a simulation to really see how amazing I really am. So as each shot is attempted, we're going to keep track of the number of made free throws and the total number of shots by recording it in the table below. And when you think you know my true free throw percentage, I want you to stop recording the shots. So in the table on your note guide, go ahead and let's see. So for one shot, we're going to see what I make. So I just need to change this to a 1. There we go. And I shoot. And you can see that down here, it keeps track that I made my first shot. Of course I did. So my current probability is 100%. I'm just going to do it as a proportion. So it would be 1. I'm going to shoot again. And I make that one. I'm going to shoot again, and I missed this time. So out of 3, I should have put make. I'm going to put make. Probably should have used like an X for making. Actually, the third one was a miss, wasn't it? Sorry. This was a miss. So my probability was 1, and now it's 0.67 is my shot at making it. Do it again. And I missed. And now my probability drops to 0.5. I shoot again. And I'm up to 5, and I made it, so my probability goes up to 0.6. Now I'm going to jump higher. Next, I'm asked if I shoot this a total of 10 times. And you can see the animation just went. And I made it 7 out of 10, so I'm at 0.7. And I'm going to shoot it, let's see, 10 more times. 10 more times. I'm going to change this to a 10. I'm skipping a couple of things here. And you can see that if I were claiming that horizontal bar to have an 80% free throw, right now I'm less than that. I'm down at 0.55. So how many times did I shoot? 20 times. 20, I'm at 0.4. Or I'm sorry, 0.55 is my chance of missing. Keep saying that wrong, guys. Sorry, I'm not very good at using the applet within this recordable version. So this should be 0.55 is the proportion of makes out of 20. All right, so I'm going to do 10 more to get 30. And my probability is 0.54 right now. I'm going to do another 10. So I just ran the simulation several times, and actually a total of 80 times you can see here, and I made it 38 out of 80, which is 48%, and I missed it 42 out of 80, which is 53%. So on your graphic organizer, I tell you to make a sketch. You're just going to do something like what you see here, and you see that as it goes over time, at first it's kind of very dramatic in its changes, but it seems to kind of be leveling out. Do you think it's going to continue to get a little lower? Is it going to get higher? So what do you think my true free throw percentage is? So looking at it, I don't know, maybe 49%, 0.49 or 49%, or maybe it's 50%. And the beauty is if you would actually click on that app, the Show True Free Throw Percentage, I actually did it, and it actually turns out to be about 55%. So how do I get this to look like it really is 55%? The next slide just told you to sketch. I already said to do that. How could we make it more accurate? Well, hopefully your brain is telling you, do it more times, a lot more times. If we run lots of trials, something as known as the law of large numbers is evident. It shows us what is happening in the long run. Probability is really about our long run averages. It doesn't really help us in the short term. So when I clicked on what's my true free throw, it looked like it was getting close to 50. It was actually 55 when I clicked the reveal icon on the applet. So if I have a 55% probability of making a free throw, what does this actually mean? Interpret this. It means that if Mrs. Stoltzfus made many, many free throws, about 80% of the shots will be made. Okay, so this is saying in the long run. So some of the big ideas about probability. Probability is a long-run relative frequency. The probability of an event occurring is always between 0 and 1, where 0 means it's impossible and 1 or 100% means it's certain to happen. Few things are exactly 0 or 1. Most fall in between on a continuum. In the short term, events are unpredictable. But in the long term, we can predict using probability. Next, we have the law of large numbers, which simply states that if we do something many, many times, the proportion of desired outcomes will approach its true probability. So let's check your understanding with a few questions. It says Pedro drives the same route to work on Monday through Friday. His route includes one traffic light. According to the local traffic department, there is a 55% probability that the light will be red when Pedro reaches the light. Interpret the probability. Pause the video and try to give me an interpretation. So I would say if Pedro drives to work many, many times, okay, so this is long run, about 55% of the time he will hit a red light. Now we're just kind of given a matching activity. It says probability is a measure of how likely an outcome is to occur. Match one of the probabilities that follow with each statement. Explain your answers to your neighbor. So it'd be awesome if you had somebody to talk this over with, but I know you're learning from home, so the outcome is impossible. It can never occur. Well, that means it's a 0 chance. Few things are exactly 0. This outcome is certain. It will occur on every trial. Well, that's going to be 1. Okay, so certain or impossible are exactly 0 or 1. The outcome is very unlikely, but it will occur once in a while in a long sequence of trials. So that's going to be very rare, but it could happen. So 1/1000th, 0.001. And then this outcome will occur more often than not. So there's probably 2 you could choose here. I'd say 0.6 or a 60% chance is the best. It's happening more often than not. 99% is it's happening almost all of the time. So I would say that that's not the best one here. Finally, gotta love this scenario. A husband and wife decide to have children until they have at least 1 child of each sex. The couple has had 7 girls in a row. Their doctor assures them that they are much more likely to have a boy next. Explain why the doctor is wrong. You hear people say this sort of thing all the time. They think it's due. Like they've had 7 girls. Their chances of having a boy are much higher. Not true. Probability is in the long run, and 7 is not enough to have that probability. So in the short term, probability is unpredictable with short-term situations. The probability that the next baby is a boy is still 50%. You see this sort of mindset a lot with gamblers. For instance, if somebody was playing a slot machine and it hasn't given out any money for a significant amount of time and they keep playing and keep playing, in their mind they're like, it's due. Any moment, it's due for a big payout. I'm going to keep playing it. Well, there is no such thing as like this law of averages. People think that something is due to happen, but it's really only very, very long, many, many, many times that the probability is going to approach a certain value. In the short term, there's no such thing. It's unpredictable in the short term.